You know, in a world where we don't have business objectives or revenue, and we just all work on interesting problems together, Stephen is the person I'd love to solve interesting problems with. Thank you all for coming and still coming. That's really kind of you. I see a lot of familiar faces, so you're a lot of friends, or I owe you something. I hope this is somewhat interesting. My name is Hooman. I'm the VP of Technology at Fastly. I made this mistake the last presentation that I did where I just sort of assumed everybody knew what a CDN was. Can I just, by a show of hands, how many people know what a CDN is? Okay, so we're good. All right. Okay, so what I'm going to talk about today for the next 40 minutes is dynamic content. And I've only been at Fastly for a couple months. I've been in the web industry, web performance industry for a while. I know the stack. I know the technology. But what was interesting as I sort of came into this world was the realization that dynamic content is actually really, really interesting. Now, I'm sure you know this. This is a sponsored session, so I'm actually allowed to talk about Fastly a lot, but I'm not going to do it because I'm actually incapable of selling you anything. But I am going to talk about stuff, obviously, that applies to Fastly technology. But what I'm hoping that you'll get out of this is things that sort of teach you about maybe where CDNs are going, things that you should probably care about when you talk to your CDN providers, and hopefully some of this will resonate with you and it'll sort of make sense as we go through it. So first of all, let's define what dynamic content is. Dynamic is kind of a bad name for it because that's just kind of what we stuck with. But basically, the way we just talk about dynamic content is stuff that's not static. So we believe that it changes all the time. Whether it does or not is a different matter altogether. I'll talk about that in a bit. But we believe that dynamic content changes all the time. With web traffic specifically, this is normally the sort of the base HTML, the first thing that shows up in a page before all the sub-resources get loaded. And HTML, because it's the first thing, it's a blocking object. It's typically larger than other things that are in the page. So we kind of care about it. It's kind of a big deal for us. So that's what dynamic content generally is in the context of web. But it's not only web that we talk about. Dynamic content can be AJAX calls, API calls, a whole bunch of other things can qualify as dynamic. Basically, it's stuff that we think of as my app logic needs to get invoked, and I got to do app thinking. My backend needs to get involved, and it's got to generate something unique, or what we think is unique. So this is sort of what we talk about when we talk about dynamic content. To give you a visual, you've all seen waterfall charts before, right? You're at Velocity. You've been here many times. Waterfall charts are really familiar. That thing up there that's got a big green thingy on it, that's a wait time. That's basically what I mean when I say blocking HTML. Typically, dynamic content, because it invokes app processing, sort of takes a while to get downloaded. And this right here for us is blocking. We don't like this because the rest of the page is totally dependent on that. This is a fake page, by the way. There's no page that looks like this. But this is just to give you an idea of what blocking content is. Or it's something that has a big blue element, which is the download element. So it's something that takes a while to download, and the page is dependent on parsing that content as it comes down before it can render the page. And that has a download element. So these are the things, these are the reasons we sort of care about dynamic content in a web context. And like I said, there's other things that qualify as dynamic content, but right now we're going to focus on web a little bit. Traditionally, when we think about dynamic content, we have had this sort of we can't cache this stuff mentality. And the reason is, there's many reasons, I'll get to in a second, but overall we've been uncomfortable with caching what we consider dynamic content because we think of dynamic content as extremely unique, extremely personalized, and it's dynamic. We called it dynamic. Dynamic stuff aren't static. So if CDNs are supposed to cache static content, they shouldn't be caching dynamic content. There's two main reasons that we have this big no caching policy. Can you guys hear me when I move my head around? You okay? You can hear me? All right, great. There's two main reasons. The first is we are petrified of serving stale pages. We just hate serving pages that are for one reason or other stale, whether they're invalid anymore or they're no longer up to date or we made a mistake. Any of these reasons really scare us. So we have this like can't cache things that we consider dynamic. That's a big part of it. But that's not the only reason. I'll get to the second reason in a second. I want to spend a minute on the notion of invalidation and caching and why we're so afraid and why we're not able to cache content that we consider dynamic. For a moment, I want to spend time on the notion of caching versus the notion of invalidation. I'm going to geek out for a second. RFC 2616, which is like my King Lear, greatest piece of thing ever written, talks about caching a total of 616 times. So if you've ever read this RFC, if you haven't, shame on you, read it many times. It talks about caching 616 times. Now, we're going to play the over-under game. I'm going to give you a number, let's say 18. How many times do you think invalidation is mentioned in 2616? Over? How many people think it's over 18 times? I picked a number too high, didn't I? How many people think it's under 18 times? Yeah, it's 7 times. So the RFC, which is a magnificent piece of literature that taught us about caching and gave us chapter 13 of 2616. I know I'm totally geeking out, but that's what it is. Chapter 13 talks about caching. It gives us so many knobs, so many layers of caching, so much control over what we can cache, but the RFC gives us almost zero guidance for how to invalidate things that are cached in the ether, which is caching networks, proxy caches, whatever, surrogates that we put in front of our servers. By the way, 5 of those 7 times is in the section that says if you use put, delete, or post, you should invalidate the content that's in the cache. So the sort of the duh section. And the 6th one is in the index, and the 7th one is towards the end where it says you should be careful for security. Now, invalidation is a big deal, right? If we're caching things, we'd like to have a method of invalidating that cache content because it's our content and we care about that sort of stuff. So we actually tried. It's not, maybe 2616 didn't give it to us, but we tried. There was an RFC or a proposal in early 2001 for the web cache invalidation protocol. If I asked you to raise your hand if you'd ever heard of this, I'm guessing nobody would raise their hand. I was just at the right place at the right time to have heard of it. We tried because it's a big deal. We care about it. So this is the difference when I talk about caching and invalidation. This is the difference. We have a lot of rules and a lot of guidance given to us by the standards community and our favorite protocol ever about caching stuff, and we have zero guidance about invalidation. So this gap is one of the big reasons that we are totally petrified of caching static content. It's not the only reason, though. So that was the main reason. We're going to spend a bunch of time on this, but it's not the only reason. There's also this notion of visibility. We also really like knowing people that are engaging with our app. And in the web world, that is a lot through the HTML base page. Google Analytics keeps track of people that are visiting your pages. That Google Analytics tag that you put in your page, that's something that goes into your HTML. All the logging that you do in the back end, all the stats that you gather, all these sorts of levels of visibility are stuff that are based on what you consider dynamic content. And that is another reason that we've been sort of afraid of caching it in the ether, because if we don't have it and if we don't see those page views, we can't keep track of those stats that are so important to our business. So because of those reasons, we haven't been caching dynamic content. Hopefully we'll think about it differently in the next 33 minutes. But right now, that's where we are. So traditionally, with CDNs, we have basically said that because we're not caching it, we're going to optimize the way we deliver it from origin. So, okay, we've decided or semi-decided that we're not caching the content, but what can we do to get this content to the user the fastest? And maybe what we'll do is we'll sort of optimize the transport. What's that mean? That means we've done things with TCP, we've done things with the middle mile. I'll talk about that in a second. You may have heard this term DSA, which got really popular for a while, and then it's not popular anymore. But it's dynamic site acceleration. It's basically delivery of content. So it's all the sort of stuff that's sort of optimized from origin delivery. Let me give you a visual representation of what this looks like. So here's a map of some country, and we have a user on one side of that country, and we have our origin on the other side of the country. And because it's dynamic content, and I can't cache it on that CDN node where I have all my images cached, I'll depend on the CDN to do some cool TCP tricks, And when it fetches the content from origin, it'll get there faster than if the user was to go to origin directly. This is one way. This is sort of an asymmetric way of doing this sort of delivery. It's not the only way. A lot of CDNs also offer you this option, which basically lets that long middle mile go through two of the CDN's nodes. You'll notice that line got fatter. That's because once you own both sides of that connection, you can do lots of tricks and you can do lots of interesting things. So you can do more TCP tweaks and maybe do interesting things within the protocol that lets you optimize that delivery, and then you get the content to the edge fastest. Except it still has to go across this country, right? So that still needs to happen. Yes, it's the best way possible for it to go across the country, but that still needs to happen. Now, there are so many advantages to being able to cache that content and get that content off of our origin servers that we've actually tried. Like, I'm talking about this like there's zero cached HTML on the interwebs. That's not actually true. There is some cached HTML, and we're trying to do this. How do we do this with today's CDNs? Well, we do some micro-caching. So we put really, really short TTLs on our base pages and our HTML content, and we let the CDN cache it for short amounts of time, and we basically send it into the ether and hold our breath. Hopefully for the next 15 minutes, everything's going to be cool. So when we put 1 year long expiries on our images, and we'll put 15, 30-minute expiry on our HTML pages. I've seen 1 to 2 minute expiry on our HTML pages. But it's not foolproof. Imagine if you're, let's say, a news provider, and you publish a news story and have an oopsie 2 minutes later. You're at the mercy of the ether, mercy of your CDN, or whoever you handed this content to for however long you told them to cache it for. I'm going to come back to this story later because it's a real story, but it doesn't fit into the flow of the presentation at this moment. We also tried something called, and we're still trying, something called Edge Side Includes ESI. Who knows what ESI is? Okay, good. So quickie on ESI. ESI is essentially partial caching. The idea is to take an HTML page and fragment it into distinct pieces and give each of those distinct pieces independent caching heuristics. And the CDN is responsible for assembly of that page before delivery. So you divide the page, like imagine you have it in a template, and you fill in the holes in that template, but you fill it at the edge. So where's my picture? You do this at the CDN node over there. So what goes to origin is essentially the truly, truly, truly dynamic content. But still, you have to grab things from origin to deliver that. The other problem with ESI is it's quite onerous. It takes basically recoding your website to define all the templates and the individual caching heuristics. So it's a bunch of work. Also locks you into a CDN, which is probably okay for us CDN vendors, but may not be okay for you. So these are the ways that we've tried to do HTML or dynamic content caching up until now. It's not great because we still feel sort of either encumbered by what we're doing, or we're not very confident with the HTML being cached, or we're being very conservative when it comes to caching this dynamic content. When it turns out, this stuff is actually a lot more cacheable than we'd like to believe. It's not as truly done. Most of it, I'm not, obviously no blanket statements, but most of it is not as uncacheable, as truly dynamic as we think. It's probably static for small, short periods of time, but it's completely unpredictable when it comes to any sort of invalidation. And this is the part that actually gets us in trouble, right? So we think, yes, it could be if I generate some content, it's probably cacheable for a little bit of time, but I don't know what that time is. And that's what scares us. So the number we pick for our cache control headers is the lowest possible that we can think of. And then we think that then we realize it could actually be lower, for example. So that unpredictability of the invalidation makes the standard caching rules that we have now not really good enough. So that's why I said sometimes when we do this stuff, we hold our breath and sort of hope for the best. But we know that if we ever did this for our dynamic content, everything would be a lot cooler. Sure, we are still leveraging the rest of the CDN infrastructure for other things, but I'd still really, really, really like to serve that content from the edge closest to my users for dozens of benefits. Imagine that waterfall that we looked at before. Remember it was blocking that piece? What if I moved that entire thing over? Yeah, Pixar is calling. That is a much better waterfall than the one that was blocking the HTML up front, right? So clearly there's performance reasons, but performance isn't the only thing. Obviously, we're going to get our page to our users faster. Things are going to get, the first byte's going to be delivered to the user faster. It's going to start rendering faster. Our users are going to be very happy. Everything's going to be great. Rainbows and unicorns. But this also has significant offload benefit for our origins, right? We don't get to see all those users. We have less bandwidth. We can scale easier. So there's lots of benefits for this, and yet we still are not being aggressive enough or comfortable enough with caching our dynamic content. So that's the problem. What would make this all better? What would make this? What would make us more comfortable with caching our dynamic or semi-dynamic or somewhat static content? Well, it needs to start with the invalidation framework. So caching, the RFC didn't give us one, but a programmatic invalidation API, let's say, or a programmatic invalidation mechanism to engage our CDN with, to programmatically do things with our CDN would be quite beneficial. It would have to be granular, and most importantly, it would have to be instantaneous. It would be sort of for naught if this invalidation that we're doing with our CDN isn't instantaneous. And this has traditionally been a big problem for CDNs. So let me go back to that media example. This is an actual example. I won't mention any names of the content provider is CDN. None of that matters. It's just to sort of give you an idea of how this materializes in the real world. It's a news provider, and they have content that they're publishing all the time. They had, I believe it was like 15-minute TTLs on their HTML, and they published a story which was basically a complete mistake. Like it was a holy shit, this is a mistake. They published it, they had 15-minute TTLs, and now they have to yank it, right? It's in the ether, it's on the CDN, and they've realized they made a mistake. Purge time with their CDN was like 12 minutes to get that one page off of the CDN. So yes, it didn't go the full 15 minutes, but they still had to basically sit there with their tail between their legs for 12 minutes. And this has traditionally been a big problem for CDNs for probably lots of different reasons, be they architectural or the need hasn't been there or whatever the reason is. It's just a problem with the CDNs. So enter the notion of instantaneous purge. The idea that as you publish something, you can at the same time publish or execute some sort of purge command that gets the old stale versions of that object off of the network, off of the CDN, off of the caches that are caching it. Imagine the same news story, and those guys that realized that the news story that went out was sort of an oopsie, and they realized that probably minutes after it went out, seconds after it went out, they had to wait. They were at the mercy of the CDN for when they can get that off the network. Imagine if they didn't have to do that, and some programmatic way to purge that content from the CDN sort of rid them of this anxiety that they had for like 11 full minutes. So that's what it means. That's what it means to do instant purging, and it sort of liberates us and gives us this ability to be able to maybe be more liberal with things that we cache. The instant part makes this predictable and deterministic, and this is the thing that we didn't have with the RFC and we didn't have with the techniques that were available to us before. So if you have the idea of instant purging, the ability and the power of instant purging, you're able to get that content off of the network as quickly as possible. It actually goes further than this. There's more to it than just the purge itself. You can do it with dependencies. So that page, let's go back to our example. We have a page that we've published, and that's got a whole bunch of sub-resources, right? And we'd like to basically purge the network or the CDN of all those objects. Well, we can, in Fastly, we call them surrogate keys. You can tag all the objects in that page, including the page with a tag, let's say tag 1 or page 1. And your purge command goes out with instead of a purge a page or purge an object, it's purge this tag. And that basically takes care of dependencies. So you can build this sort of into the purge statement or into the content itself and be able to basically purge entire trees of content with all the dependencies. This is what instant purge sort of gives us. This is the power that it gives us, and this is how it allows us to do things that we couldn't do before. But this actually goes above and beyond invalidation. Here, I'm going to step back for a second and get a bit philosophical with you. So dynamic content for me, and what we can do with it had we instant purge, if we have instant purge, is sort of a symptom of something bigger, and call it an evolution of the CDN, call it the next step in technology, call it whatever you want. I sort of see it as something that's been influenced by the way we have interacted with clouds. The notion of programmatic infrastructure, like infrastructure as code. This is sort of changing the way that we're looking at CDNs. We see this in our customers. I'm sure you guys notice it. I'm sure all the other CDNs are noticing this as well. We can't look at CDNs as a sort of a black box anymore. It's not this. It can't be this unknown that we have no control and no visibility and no sort of. We got to have our tentacles in there somehow. And I think this is somewhat motivated or encouraged by the way we've used clouds. We have to think of the CDN these days as sort of an extension to our app. The same way that we think of services that we use, cloudy services or semi-cloudy services that we use as an extension to our app, and we can programmatically change them around, we should have that same expectation of our CDN. We should have that. We should interact with our CDN the same way. Can't be a black box. We have to do real-time integration. That's the part that's actually exciting about the future, I think, of this industry, is that you can integrate your app with your CDN. It's very cliche. I don't want to be another AAS, like whatever as a service, but it's kind of like content as a service, right? Or, I don't know, delivery as a service. Call it whatever you will. But it's something that's programmatically controlled by you. It's your content. You need to have this control. And we're seeing more and more people start thinking about their CDN as that extension of the app. It has to blend into the app really, really well. This materializes itself in two ways to me. The first is this notion of control. We already talked about purging, but it doesn't stop there. It's also configuration and programmability in general. We have to have an API. This API needs to be instantaneous. We have to make changes to our network, changes to our configurations right away, instantaneous. We have to be able to invalidate and purge things instantaneously. And all of that needs to be very quick, obviously, and needs to be very granular. Let me give you an example of caching policies that are granular and give us control. Imagine, this is actually from a real customer. It's a travel site. I can't tell you who. It's a travel site that wants to provide micro-geo-targeted content. So people that are standing in JFK will see a different set of hotels available to them than people that are standing in Grand Central Station. Now, normally, that's dynamic content, right? That's the stuff you have to have some sort of app logic figure out, is this guy standing in JFK or is this guy standing at Grand Central? Imagine as part of your hash key, the geo-IP information, and you were able to cache in your CDN a different piece of content, dynamic content, for the guys that are at JFK versus the guys that are at standing in Grand Central. That's the idea. That's when I say control, that's what I mean by control. It's to be able to configure, to be able to invalidate, to be able to control the caching heuristics and the caching characteristics of your content, all of them, programmatically or otherwise, and all of it needs to be very, very instantaneous. This basically means we move some of the app, maybe more than we are comfortable with at first, some of that logic to the edge. In Varnish, Fastly uses Varnish. How many people know Varnish as a great? So you guys know VCL, the Varnish configuration language. I'm new to Varnish. I've just been playing with it for the last couple months. But the fact that the config file looks like a script, like reads like a script, like if there are if-then statements in the config file, sort of is what led me to this whole notion that this is sort of, I have a level of control over my content, over my configuration that I'm not used to. And it's sort of enabled by that. I'm going to show you a snippet of VCL in a little bit. So that's kind of control. It's being able to move some of that logic that normally we have at the app itself into the edge. Now, this isn't purely dynamic content, which is what we're supposed to be talking about here, but it is a wider umbrella of having control and having the CDN be a part of our application, an extension of our application. It doesn't stop there. So if you think of this extension notion as having two pillars, one is control, the other one I think is visibility. We talked about that earlier, about one of the reasons that people don't cache dynamic content is because they would lose some visibility. So if you're going to move some of this logic and some of this power to the CDN, you should be able to get some real visibility into what's happening on the CDN. This is two different things. You have analytics in the form of stats, be they network stats, HTTP stats, TCP stats, and the stats API that gives you all that stuff, and also logging. You lost all that logging if you're moving a lot of this content to the edge, so you should be able to get real-time logs from your CDN, hopefully stream to a log destination of your choice. So what would have been a log processing engine behind your servers before could just be an endpoint for log entries just being streamed to you from the CDN. So that's the notion. So let me give you a quick summary up until here. We talked about dynamic content. We talked about how it can be cacheable, and the reason we were crippled in caching dynamic content was the lack of a good invalidation framework. So we'd like a nice programmatic invalidation framework that's instantaneous. That's the key. It has to be instantaneous, otherwise it doesn't serve its purpose. And if you step back for a second, when we look at CDNs as we sort of analyze their evolution, and we become all professors of CDN history, analyze their evolution, it's we need control. It needs to be seen as a sort of an extension of our application. We want control, we want visibility, we want all the things that we expect from a service that we're using as a part of our application. I'm going to give you a couple of examples of sort of these things in action, and then hopefully that'll give us a little bit of time to maybe get some questions answered too. So the first example I want to show you is the notion of Purge. I want to show you a Purge example, and this is with CMS and it's with WordPress, which you guys all know. So here's a traditional WordPress deployment, right? You have users, you have a CDN that's sort of in front of your WordPress installation. You have WordPress, you've now published a post, that's this little thing right here, and somebody comes in over the CDN and grabs the content and you serve it to them. This is how things were before, right? Now you realize you made a boo-boo in your post and you got to go edit it. And as soon as you edit it, you get dozens of comments. People come in and comment about it, and you have fights happening in the comment section, et cetera, et cetera, et cetera. You know this. And because all that stuff needs to happen on the WordPress side, you've never cached this. You don't want any of this to be on the CDN node because you haven't had invalidation in the past, and all the stuff that happens, all your edits, all your comments are not reflected in the cached copy on the CDN, right? And this, those of you who've done things with WordPress will look familiar to you. This is kind of a waterfall from a sort of a typical WordPress. I'm not bad-mouthing WordPress. There's probably lots of plugins with this particular one. This is not a high-profile site, but it's got 10,000 hits every week. It's got page views. And those two big green bars that you see up there, this is a WordPress hosting site on a WordPress hosting platform. Those two big green bars are basically how long it takes to generate content. That first one up there, that's a redirect. It takes, a second to redirect. And then another second and a half to actually generate a tiny, tiny bit of content. And look, all the rendering doesn't start until that thing comes in, right? CDNs let us get rid of all that stuff, right? Because we can push that stuff to the edge and the server doesn't have to do its thinking. So that is what the old model was basically relegating us to, because we weren't choosing to cache those two things. The second thing, we can do something with the first one too. I'll talk about it later. That second thing. So what's the new way look? Okay, we still have our WordPress site. We have now published our article, and request comes in, and the response, we let it be really cached on the network. Now, a cache control header of long time totally isn't legal, isn't a normal thing, but you get the point. So you tell the CDN that it's allowed to cache the content, the page is served, and now it sits on the CDN node, and everybody who comes and does a request for this object gets it from the CDN directly. It's faster, the greens went away, everybody's happy, things are really cool. But now you start editing, you start commenting, all this sort of stuff happens on the sort of the origin side, and you got to make sure that stuff is reflected in the CDN. So imagine that as soon as that stuff happens, a purge command also goes out to the CDN. And the purge command invalidates the object at the CDN. That needs to be instantaneous, right? I keep coming back to this notion of instantaneous, because if you issued that purge and then it took 12 minutes for that thing to not be in the cache anymore, the whole purpose of this goes away. It needs to be instantaneous. So the moment you issue that purge, that object goes away from the edge node, and now the entire cycle begins again. And, rinse and repeat, basically. So this is a really good example of how Purge lets something that has traditionally been seen as a non-cacheable object. As a matter of fact, I think, if I'm not mistaken, WordPress by default marks all pages, base pages, as strictly no cache, no store, like the strictest of no caching headers. This is the way it was. If you have instant purge and you have the ability to control that invalidation at the edge through a programmatic way, then you can put that stuff on the edge and get caching of content that you typically didn't think would be very cacheable. Let me go to my second example. You guys know what beacons are? Are we cool with what beacons are? Generally, tracking something or another, tags in a page that ship, that make a very tiny request to some sort of tracking server that all it does is basically keeps track of the requests. The content that it is exchanged is actually not that important at all. Google Analytics uses it. All RUM measurements basically use it. So imagine that you could do that beacon termination. You may have your own beacons. You can do that beacon termination at the edge. So the old way is this. Some page gets loaded on a browser and a beacon gets fired. From that browser, the beacon is being fronted by a CDN. It goes through a CDN edge. It makes its way to the origin. The origin responds. Normally, it's a 1x1 pixel, like a little tiny 1x1 object, image, 35 bytes. It's nothing. It's not material to the rendering of the page whatsoever. But it is now a log entry in the origin, and there's some sort of log analysis that happens in the back. Well, that origin infrastructure needs to be able to sort of absorb all these beacons coming in, right? There's lots of stuff that's coming in. You have to have a server that terminates those. You have to generate the log files. You have to have your log analysis engine, et cetera, et cetera. Imagine if you moved this and did it all at the edge. So the request comes in, but now your CDN node is the one that serves that 1x1 pixel. And it serves it right there. It never gets to your origin, but you're like, okay, but I lost my log entry. Did you? Imagine, I'll talk about this in a second, imagine that you took that log entry that you would have normally seen on your backend infrastructure and now streamed it directly to a syslog daemon, daemon, I don't know what it's, syslog server, an S3 bucket, some sort of FTP, or whatever sort of endpoint. You can have syslog services that can absorb this stuff for you, whatever your endpoint is, and your CDN through real-time logging and real-time basically streaming of logs enables you to gather that stuff in a place and totally takes the burden off of your origin for gathering and not analyzing, but obviously gathering the log entries that result in the analytics that you're trying to gather. This right here, some beacons, I don't know if you've ever seen this, 204 is a special status code. It basically means there's nothing in the response. You can actually generate that, if you have enough control over your CDN node, you can generate that directly from the edge with no content whatsoever. And I'm going to talk about that in a second in a different example. So basically, the point of this story is your origin is totally unburdened from having to take that hit from all those beacons, and your CDN, if you have enough control over it, is able to give the response to the client and then stream all the log entries to whatever streaming endpoint you choose to have. My final example is purely edge-generated content, and this is a real example from a partner of ours. We have a partner that does lots of, where are the Sodexis guys? I think they're here. There's Jacob's out there. That does lots of measurements of CDNs. And we'd like to know which data center the particular request has ended up in. So there is some sort of request that goes out into the world, into the CDN, that says, hey, give me a JSON object of which data center I've ended up in. That's, in a response to that, a purely edge-generated piece of content. I can actually generate an entire JSON object that says, hey, you ended up in San Jose. That's a fully dynamic piece of object that's generated by the CDN itself. Traditional ways would have had that content go to the origin. You'd put a header in that request to origin that said which edge it came from. The origin generates the JSON. All that stuff happens at the origin. Here you have a piece of content that is essentially wholly generated from the edge to whatever the agent is that's requesting it. This is done through VCL. I just want to show you the VCL snippet really quick, just so we say we had some code in our presentation. This is what it looks like. You kind of have to do it in a 3-step process. You generate an internal error. That's a 900. Then when you're delivering it, you make you put application JavaScript as the content type, and then you generate the content in this sort of error section in lines 17 through 23. This is not the only example of this. There's lots of other examples, a bunch of them on our blog. The first one talks about how you can cache with tracking cookies. So this notion of cookies make things uncacheable is not entirely true. So it's using a instant purge and instant invalidation as the basis of caching content that has tracking cookies involved. How you cache API calls. That's a link to the third part of a 3-part series that has links to the first 2. And here's a blog post on log streaming. So there's lots of examples of this, and all of these come from the notion of having control and visibility, control over and visibility from your infrastructure, CDN in this case, to be able to control it, instantly purge things, instantly push configuration, change things, engage with it through APIs, and then see what's going on. So let's sum up. I think we have a couple minutes left. That's good. Let's sum up. We talked about how dynamic content is very cool. It can be cached much more than we think, but in order to cache it, we need instant purging. Without instant purging, we can't do it. That's the way we get control over the content at the edge, and we can get rid of it when it goes stale or is invalid. We, at the same time, need real-time logs and stats because we would have lost some visibility by not seeing every request come to origin for that content. We've lost some visibility. We'd like real-time logs and stats, preferably streamed to an endpoint of our choosing. That real-time integration with a CDN is pretty cool. It's nice to be able to engage the CDN through APIs that are extensive, granular, and give us control and visibility into the CDN. And when we have those, we can get very, very creative with things that we can do with our CDN, which is now a part of our infrastructure, an extension of our app, which is kind of the point. And we also obviously learned that we should never use long time totally in a cache control header. But if you ever do use it, please send me an email. I'd love to see it. That's all I have. I think we have a couple minutes for questions. If there's any questions, I'm happy to take them. Or if not, you get to go home. Yes, go ahead.
2 points. One is the instant purging.
Yes.
Some instances where you don't want to have an instant purge, especially if you're gated by capacity on the origin.
Right.
And you don't want to have an avalanche coming back from
right.
the edge nodes.
Right.
So you may want to have staggered purging as opposed to instant
right.
purging in that case. Second point is the dynamic content.
Mm-hmm.
I think it's a misnomer, like you said at the beginning, to use the word dynamic.
Right.
Like a user's inbox is unique per user, so there's no advantage in having a CDN do edge content delivery for inboxes. But if the content is unique per region or
right.
per language,
right.
country, maybe you can extend the word dynamic into static to live.
Yeah, or semi-dynamic or something like this. Yeah.
It all depends on how many users are behind that edge node that will share the same content.
Or that's a part of it. It's also the length of time for which it's static. We can have, I mean, we call them all dynamic, but there are dynamic content pieces out there that are dynamic as a whole because they're generated every time, but they're static for short periods of time. And that's a really good example of how we've been afraid of caching that stuff, but it's actually pretty cacheable stuff. The regionalized content that you're talking about is a great example of how caching control can let you sort of pick and choose who gets what, as long as you can have control over the hash that governs the content. So that's to your second point, the fact that dynamic is a terrible name. It is a terrible name, but I think that I would have not filled the room if I used opaque terms. Thank you all for coming, by the way. The second point you make, the staggered purging, is a really, really good point. So one of the ways that you can handle that, first of all, the purge needs to come from the app. So the staggering is something that you can control because you have control over the edge, right? The surrogate keys that I talked about earlier, how you can basically create dependencies, is a very good way to sort of get your staggered purging out from your CDN. Imagine that you have 1,000 pieces on the CDN, some dependent on others, and you've created, I don't know, let's say a tree of 10 different keys or 10 different sets of dependencies. Your app can get to choose which one of those tags get purged at what interval as you choose to go down it, and that's a way to get staggered purging into it. And that, I think, is actually the beginning. I think there's ways that we can do that better. There's probably a way where you can tell me, stagger purge this, and I start shoving it through the network, but at a slower pace, because you don't care about serving stale content for a few minutes.
I just worry that people might try to do instant purge globally, and then they end up with an origin that's...
Yeah, but so the thing you have to remember is an instant purge is different than an instant purge all. There's one thing to purge the entire CDN of all content, which is a purge all, and it's a completely different thing to purge an individual object. And whatever control you expect from your CDN, as you engage with your CDN, should give you both of those levels of control. Anybody else? Yes?
Player out for
Oh, we got to go. Thanks, guys.